Welcome back to the channel. In today's video, we'll be completing the end elevation for the given drawing. So in the previous drawing, we drew the line of intersection for the cylinder and the cone. What we'll be doing in today's video, we'll be completing, as I said, the end elevation. All right. So the first thing we're going to do, we're going to set out where we're going to draw the 45-degree lines, okay? So if you have your T-square and your set square, we draw those vertical lines here. So this line will be coming from where the semicircle is, right? And this line is the same distance that we have from this line drawn from the semicircle to the base of the cone, represented by a triangle. Right, so this distance from here to the end of the triangle is the same distance from this line to the end of the triangle. All right, the next thing we're gonna do now, we're gonna draw 45-degree lines from those lines, okay? All right, having done that, the next thing we're gonna do, we're gonna draw lines from the top of the cone going across, all right? We're gonna do the same thing in the plan so that we have established what we have done. We have drawn the height that we would need in the end elevation, okay? All right, now we're gonna draw another line from here as it was a little bit short. So you would have used a T-square to extend the line. All right, so we're gonna draw lines from the center of the circle to intersect this line, right? So we'll go run it from the center, draw there, enter. We're gonna do the same thing from here, right? All right, so here we need a line going down there, a construction line there. We're gonna draw a line from here, going across there, and then we are going to draw the vertical line going up, right? So from this intersection, going up to this line, we're gonna do the same thing here, there. I'm gonna go up to the baseline. All right, so we're gonna carry also the center line going up to the baseline there, right? All right, this line would go straight up to the top there because that's the top of the cone. All right, so we're gonna draw the sloping sides now to get the side of the cone. All right, so that's our cone. Okay, the next thing we're gonna do now, we're gonna complete the, what would you see when you look from this direction? So when you look in this direction, what would you see? A circle. So all you need to do is just carry the center line across there, enter. You're gonna carry the base of the cylinder there. Oh, that enter. Gonna carry the cylinder across, right? And all you need to do now is to draw a circle. All right, so go circle, center, radius, hold on. So all you need to do is draw the circle there. And if we project it in a plan, we will know where it is. So I'm gonna go there now. Watch. Line from there We're gonna come across there, and then we're gonna go up. Uh, all right, so we're gonna go line, line from there. We're gonna come across from here, come across, gonna go up. All right. So here now we can draw the circle. All right. So go center, radius, right, and there's the circle. All right. Okay, so that this will be the completed end elevation. What we're gonna do now, we're gonna darken it, all right? So you're gonna take, if you're using a pencil, you use a 4H pencil. I'm gonna come like this, there, 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 enter, right? Then we're gonna draw the circle, a circle, center, radius there, enter. So this will be the completed end elevation, all right? So the next thing we're gonna do, we're gonna label it, all right? All right, so here we have it, the end elevation, right? The next thing we're gonna do, can I guess what we're gonna do on it? We're gonna put on our center lines, all right? All right, so we're gonna draw the center line. So we're gonna go line. Here's our center line. We're gonna continue with this one too. So there, going up, that's our center line. Gonna continue the same thing here. There's our center line. All right, so we're gonna do the same thing here. Here's our center line. All right. All right, so we're gonna draw another center line for the plan for the end elevation. That's there, there. Oh, this one wasn't horizontal. All right, so this one is not at the right place. All right, so we're gonna go again. So line from here, good, and then we go across again. That will be the center line for the circle. Okay. All right, so we have our center lines for the end elevation, right? And we have our plan, right? So this brings us to the end of today's video. In today's video, we looked at how we draw the end elevation for a cylinder, horizontal cylinder that's intersecting a right cone, right? So we have put on our center lines, we have labeled up the drawings, front elevation and plan. And if you want to see how we got the first two drawings, which was at the beginning of this video, which is the front elevation and plan, you can visit the previous video, right? So the previous video, we looked at how we drew the front elevation for the intersection of a horizontal cylinder and the right cone, and the plan view for the same horizontal cylinder intersecting a right cone. So you can visit that video. This video now is like a part two to continue to finish the end elevation. So thanks for watching. Thanks for joining us. And in the next video, we'll be looking at centroids, right? How do we find the center of gravity for a given irregular shape figure? All right. So in math, You could find the area for a circle, area for a quarter of a circle, area for a definite geometrical shape such as a square, rectangle, trapezium, parallelogram, but we're using graphical integration and centroids to find the area of an irregular shape object, meaning it's not a shape that is common, such as a circle, triangle, rectangle, polygon, right? It's a combination of those geometrical shapes to give you a different shape, right? Which you would not be able to find the area easily using a mathematical calculation, right? So the thing would look like maybe a segment of a circle on top of a trapezium or a parallelogram, and it would be easier to use graphical integration and centroids to find the area of the object and the center of gravity for the object, right? So that's what we'll be doing in the next video. All right, this brings us to the end of today's video. In today's video, the topic was intersection of solids, part 2 of 2. So the first part, which is the first video, right? Part 1 of 2 was the first video showing you how you draw the front elevation and plan for a cylinder which was horizontal to the horizontal plane and it intersected a right cone. So we drew the front elevation and plan for the video that is labeled part 1 of 2, which is the first video. In today's video, which is part 2 of the two-part series of this topic, intersection of solids, with respect to the cylinder and the cone, we drew the end elevation for the cylinder and the cone, which was intersecting, right, at right angles to each other. So we thank you for watching the video. We thank you for supporting the channel. The name of the channel is CAD with Mr. Hugh. And in the next video, we'll be looking at graphical integration. How do we find the area for a given geometrical shape that is not necessarily a common geometrical shape, such as a circle, square, rectangle, polygon, or uh, trapezium, right? So we're looking forward to seeing you in the next video. So thanks for watching. Take care until we meet again. Bye. Thanks for watching the video. And don't forget to subscribe, hit the notification bell, like, comment, and share.